My name is Patricia Klein, and I am currently a postdoc at the University of Minnesota. Um, I am a commutative algebraist, and I tend to like studying the commutative algebra that comes from problems that originate in adjacent fields of algebra, for example, representation theory and algebraic combinatorics. In the latter case, I'm especially interested in commutative algebra in Schubert calculus. So what is Schubert calculus? In the 1800s, Schubert started to ask questions like how many lines intersect a given four lines in free space, provided they're in sufficiently general position. And so these sorts of enumerative questions were things that he gave some sort of rough answers to, and Hilbert's 15th problem was to make that rigorous. So in modern Schubert calculus, we study the cohomology ring of the complete flag variety, which has a presentation under Borel's isomorphism as a polynomial ring over Z, quotiented by the non-constant element, the ideal generated by the non-constant elementary symmetric polynomials. And so this has a basis given by what are called Schubert polynomials. And understanding the constants that appear that determine the multiplication structure on that ring is something that has generated a lot of interest in combinatorics. And that combinatorics then pulls us back to commutative algebra. So one way that the combinatorics gives rise to some really exciting commutative algebra is that some combinatorial formulas that are out there for double Schubert polynomials involve these things called Pipedreams, so introduced by Miller and Knudsen, and bumpless Pipedreams more recently introduced by Lamley and Shimazona. And so it turns out that in work due to Knudsen and Miller, we find that the Pipedreams can be described in terms of an anti-diagonal Grosvenor degeneration of the defining ideals of matrix Schubert varieties, which are related to Schubert varieties. So matrix Schubert varieties are generalized determinantal ideals or varieties. And in joint work with Anna Wygant, what we showed was that bumpless Pipedreams actually can describe the components of the initial ideal under a diagonal degeneration. So this Grosvenor geometry and these combinatorics tell us surprisingly much about each other. And that relationship and how it extends, for example, to the symmetric setting or the skew symmetric setting is something that I'm still very interested in thinking about.